All right, guys, this is day one of graphing polar equations. You are going to use your calculators, and I made a video to show you how to enter everything in your calculator. So this video is really just pulling that information off the calculator and just graphing it and then making it look like it needs to look. Okay, so the first one is 4 cosine theta. I have already pulled the information off the calculator just to kind of save time. So once you have your theta and your r, it's just, you're graphing points. Now I know technically when you write points in polar form, they need to be r theta, but it's just, we pull it off the table at theta r. So that's totally fine. So when you do this, theta is 0, my radius is 4. So I go put a point at 4 comma 0 really is what it is. At 30 degrees. Now remember, in your calculator, it's going to be in degree mode, which is, it's just easier for us to read that. But obviously when we go to graph it, we are graphing it in radians, and 30 is pi over 6. So at pi over 6, I'm going to count out 1, 2, 3, roughly 3.5. I mean, it's 3.46. So you just kind of, eyeball it. It's not a huge deal. At 60 degrees, we are at 2. So at pi over 3, I'm going to be 1, 2. At 90, I am back to 0. At 120, now remember, and I'm going to draw a little bit that doesn't kind of make sense. Remember, this is 120 degrees, right? But remember, this radius is negative. So instead of me going out on 120 degrees, I go backwards, right? So I'm going to go the opposite direction. So I go, instead of counting up in the second quadrant, I'm going to count down in the fourth quadrant. So down 1, 2. And then 150 is, 150 is at 5 pi over 6. But again, I'm counting in the opposite direction. So I'm not going to be up here in the second quadrant. I'm going to be down in the fourth quadrant. So I count 1, 2, 3, and roughly a half again. And then at 180, I would be at 1, 2, 3, 4. But I'm not going to put a point there because remember, it is -4. So really, I just go back and I'm going to put a point back where I started. Now, remember, you only have to grab enough points off the calculator to make your shape. And obviously, I've backed the place that I started. And if you remember from yesterday, technically, r equals 4 cosine theta, if we were to change that into a coordinate, or a rectangular equation, it would be the equation of a circle. So I've got all my points. I'm going to make a circle. Oh my gosh, that looks terrible. Do a better job than I did. Sorry, guys. Again, I just have already written everything out so that it's there so I can save a little bit of time. So I pulled all this information off the calculator. And when I wrote my table here, you'll notice that instead of writing it as 30 degrees, I just switched it over to radians so it was easier for me to graph it. So at 0, we are at 0. At pi over 3, we're going to be at 1/2. So at pi over 3, it's going to be just like right here-ish. At pi over 2, we're going to be at 1. At 2 pi over 3, I'm going to be at 1.5. So there's my 1.5. At pi, I'm going to be at 2. So 1, 2. Okay. And then at 4 pi over 3, I'm down at 1.5. So 1.5. Right? I'm just counting. Remember, the radius is just the number of circles out from the origins. It's, obviously not the correct mathematical, technical definition, but that's really what you're doing. At 3 pi over 2, I'm going to be at 1. At 5 pi over 3, I will be at 1/2. And then again, back at 2 pi, I will be back to 0. So I went back to the original starting point. So that is enough to give me the shape that I really need. And guys, when you're looking at this, you're obviously going to pick, when you're going to pick your points off your calculator, you're obviously going to pick, the angles that you have here. And again, and I can't remember, these might all be roughly rounded, and that's okay. You're getting an estimate. I actually think these are actually all right. Those are not rounded. The next one is rounded. I apologize. All right, so here's the next one, 2 plus 2 cosine theta. And I just did 3 of them because, once you do a few of them, you kind of get what you're supposed to do. there's a lot of points here. And this is what I mean. Like this was 3.73, blah, 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 blah. I didn't remember. This is 3.41, blah, 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 blah. I don't really care. I know it's roughly 3 3/4 and roughly just under 3.5. So that's really all I care about. So I'm going to go graph at 0 degrees. We are at 0 radians. We are at 4. At pi over 6, we are going to be at 3.73. So I'm counting out, and again, roughly 3 3/4. It's not going to be exact. It's okay. At 3 pi over 4, I'm going to be roughly 3.5. The only thing you really need to do is obviously 3.73 should be out further and 3.41 should be in, so that's why I fixed that. At pi over 3, we are at 3. At pi over 2, we are at 2. I can't read it. Okay. 2 pi over 3, we are at 1. So at 2 pi over 3, we are at 1. At 3 pi over 4, we are at 0.59. All right. So roughly there. That's terrible, but that's all right. And then 5 pi over 6, we are at 0.27. So roughly there. Not the greatest, but it's okay because I'm working with the iPad. You can make it a little bit easier or a little bit neater on the paper. And at pi, we are at 0. Okay. At 7 pi over 6, we're going to be at 0.27. Okay. So 7 pi over 6, we're at 0.27. So I'm back out here-ish. At 5 pi over 4, we're going to be at 0.59. So now it's a little bit further out than when I was at 3 pi over 4, but that's all right. At 4 pi over 3, we're at 1. That we can actually make a little bigger. And then 3 pi over 2, we're down at 2. At 5 pi over 3, we're at 1, 2, 3. At 7 pi over 4, we're going to be at 3.41, so roughly there-ish. At 11 pi over 6, we're going to be at 3.73. I apologize. And then at 2 pi, we are back to 4, right? So we're back to where we started. So then we just kind of make our shape. And again, remember, your graphing calculator is going to give you the shape that you kind of need to look at. Oh my gosh. Let's see. Oh, I was doing well. Not anymore. Oh, crap. Not anymore. Oh, no. The whole thing? Of course. We'll try it again. All right. I'm going to stop there just in case I have to undo again. There we go. Okay. Again, this section is pretty easy because it's just straight up calculator work.